Good morning, Amira. How are you?
Good morning. I'm okay, Neil.
I'm fine, thank you. Um, just give me indication of where you are at the moment in your syllabus and what work have you completed.
You gave me homework the last time. It was the vector homework.
We did some vectors in 2 dimensions. Do you remember that?
Yeah.
Did you complete any work and do you have any questions on that work?
I completed the homework. I didn't have trouble, but I'm not sure if my answers are right.
What homework are you referring to? The homework in your textbook?
No, we
I
didn't have
see.
our textbooks last week.
Did I send you
So you
something?
just gave us, yeah.
Ah, okay, interesting. I can't remember that. I won't. Okay. Um, what did it look like? Do you have my number that you can just quickly send me a photo, or just give me well, if you have your phone with you and you can take a photograph of that and send it to me, then we can look at the stuff
Okay.
that you are struggling with to start off with, and then I'll give you something else to do. Could we do that, Amira?
Okay.
I don't even know if I've got your number. No, I don't. Oh, there we go. Okay, I'll have to. Oh, I gave you that one example. Awesome. Okay. So I couldn't remember what work I gave you. Okay, so we did the concepts and we did some examples with components. And this is the one example that I gave you as homework, isn't it?
Yes.
Okay. Just paste your stuff here. Okay, so you've got your answer there. What I'll normally do, I'll find a memo for you and I'll send it. You can always text me during the week and say, look, I've completed the stuff. Where's the memos? Soon you'll be able to actually get the memos. I'll show you how. Okay, let's start. Just the format or the way we're going to do these things. To get the resultant vector, would you agree with me? The resultant vector would be somewhere here. If you pull, if you've got like a stone or something, and someone is pulling it straight up, and someone's pulling it to that side, the resultant would be here in that direction. It will actually move in that direction. So we at least know that the resultant would be in that direction. So this is the method we're going to use. You're going to get the X and Y component. So we're going to get the X component of, let's say this is force 1, the red one. And you would agree the X component is just 0 Newton.
Yeah.
Okay. And you don't give directions for 0 Newton. There is no direction. And then the Y component is 100 Newtons north. No calculation is needed. Is that correct?
Yeah.
Good. And then we need the X and Y component of the 120 Newton force. So the X component is what? Sin or cos?
Cos.
Very good. 120 cos 40. Did you get a value there? I can't see. I've made your stuff too small.
Yeah, I got 91,9253.
Okay. 91,9253 Newtons. And this is like east. And then the Y component would be 100 sin 40. What's that? I think you've got like, I don't know.
77,1345.
Yeah, it's safe to keep 4 decimals, and this is south. It's safe to keep 4 decimals. We're going to round off to 2 decimals only at the end. Right, so now your the sum of the two components. So you did that, okay? Well, excellent. So the resultant X component, or the total X component, resultant is good, is 0 plus 91,9253. And that is just 91,9253 Newtons, and that's east. And then you did the result of the y components as well. Now, the one y component is north and the other one is south. So I normally choose the bigger one as a positive value and the smaller one is a negative value. Okay, just doesn't matter. You can make north also negative. So that's the y component of the first vector plus, or the force, the second one, and that is 100 minus, did you also do this?
Yeah, I did that.
And what's that? It's like 23, 22.
22,8655.
I think you are gonna get the sum right. That's north. And then did you use Pythagoras to get both of them? So you would say f res is the root of 91 comma something square plus 22,86 square. You put in all those values. Just going to look at your next page. You did that and you got, was it 94?
94,7264.
Awesome. And now you need to get that direction. Okay. How would you get that?
I took the 94,7264 and I divided it by 91,9253.
Okay, let's just quickly look at that. So the one component was 91 east. So the one component was 91,9 something 92 east. And the other component was only 22,86 north. Is that correct?
Yes.
So if I make a triangle here, or you can make a rectangle there, then this angle, I'm actually looking for this angle theta here. You see that?
Yeah.
And that is, you can use alpha also. Alpha is maybe easier. Tan of alpha is opposite, which is 22,86 over adjacent, which is 91,92. So you made a small mistake there. You chose the two 90s instead of a 20. There's one of the resultant vectors or forces is 22 and the other one is 91. You used the hypotenuse side. So if this is my triangle, then this one was 22,86 and this one was 91,925. And then you got 94,7264 here. And we're looking for this angle there, alpha. So you can use tan of alpha, but then you must use 92. You used 94 over 91. So you wanted, I don't know, the different angle. Okay, it's just a small mistake. That's why drawing this is very important. Okay. Got it, Amira?
Yeah.
Good. Okay, let's just quickly do that. Shift tan 22.86 over 91.92. And that's about 13,97 degrees. So alpha is 13,968. Let's say 97 degrees. I'm just going to keep that. So therefore, the angle theta is 90 minus that. So I'm just going to do 90 minus answer. Then I get 76,03 degrees. Now it might be that your textbook uses from north or I don't know, direction from north, but according to the CAP syllabus is sufficient just to give the degrees if you are working from north. Good. Okay, what I'm going to do quickly before I forget, I'm going to give you some work on this. So you haven't got your textbook yet?
I do have it.
Okay. You need to put an hour aside a day for science. Simple.
Okay.
Otherwise, you are going to struggle going through the syllabus. Okay. what I'm going to do, I'm going to add some homework for you with a memo. Okay. Right. Okay. Good. So what we've done now, we've done vectors in 2 dimensions. And the important thing is that these vectors are not in equilibrium or rest. In other words, what I'm trying to say, what did I do now? Delete this. What I'm trying to say is the following. Very important. If we have an object here and someone is pulling in that direction at 50 newtons, and someone's pulling in that direction at 40 newtons, then this object is going to move. It is not in rest, or the forces are not in equilibrium. Have you heard that term?
Yeah.
Okay, so these forces are not in equilibrium, so that object is going to move. Okay, so the method we're going to do is components. But there are also forces that are in equilibrium. In other words, if I add another force, let's just do that. If I add another force, say for instance in this direction, at a specific angle and a specific value, then these 3 forces can all balance one another. And then they are in equilibrium. And then there's 2 methods to determine the resultant vector, or the tension in a rope, or you can, if I want to determine what this force is, there's 2 methods of doing it. And I'm going to show you how to do that. That's new work. Okay, but before we can do that, there's a little bit of trigonometry that we must be able to do first. And this is very important today. Okay, you are able to solve angles and values in a right-angled triangle. So if I give you this as 60 degrees, and I give you this as unknown, and I give you this as 100 newtons, then you can actually solve this unknown. Do you agree?
Mm-hmm.
So you're just going to say what? Sine 60 is whatever known over 100. Is that correct? Amira.
Yeah.
Okay, good. We must also be able to work with triangles that doesn't have a 90-degree angle. This is new for grade 11. You're going to do that in maths too. Right. So now I'm going to show you what is called the Syn Rule, or the Syn Rule. The Syn Rule basically means the following. I'm just going to show you the one part that you need. A over sin A equals B over sin B. That's the only part of the Syn Rule that you must know. Okay, that doesn't solve anything for you. I'm going to show you what it actually means. If I have a triangle, and let's assume this angle is 62 degrees, and I have a value here, which say like 100 newtons, and I've got an angle here of say 40, let's just do a 40. Let's say 40 degrees. And I have an unknown value here, I'm going to call X. Then we can solve X by doing the following. Let's draw these 2 lines. So would you agree that the 100 Newton is actually opposite the 62 degrees, and the 40 degrees angle is opposite X? Those 2 are opposite one another. So these 2 are mates, and these 2 are mates. So if I want to know what X is, I'm just going to put X on top. So X over sin of the angle opposite it, 40, is 100 over sin 62. So I've got the side on top of the angle. I've got the side on top of the angle. One of the combinations I've got both values for. And then I'm just going to multiply with sin 60. I've sin 40 right through. Then I get X equals 100 sin 40 over sin 62. Type that in your calculator. So you get 72,80.
Yeah. Yeah, 72,80.
Okay, good. Take a screenshot of that. That's kind of important, really important actually.
Can I ask a question
Yes,
quickly?
obviously.
Why did we multiply all by Syn 50?
Because it's just the equation. So for instance, I had x over 10 equals 4. Then I'll multiply with 10 through to get x equals 4 times 10 on that side. So when I multiply by 10 on the left-hand side of the equation, that denominator just cancels. So I multiplied with Syn 40 on both sides. I'll quickly show you what I've done. So we had the following. We had x over Syn 40 equals 100 over Syn 62. So when I multiply with Syn 40 both sides, the Syn 40 cancels here. Do you understand that?
Yeah.
Hmm?
Yeah.
Sorry?
I say, yeah. Yeah, I do
Okay.
understand.
All right. And then on the right-hand side, I'm just going to multiply the 100 Syn 62 with Syn 40 over 1. And that's exactly the same as that.
Okay.
I just did that so that you can write the whole sum in one step. You could have also do this step first. Just put 100 over Syn 62, and then the answer you get there, you just multiply with Syn 40. You'll get the same value.
Okay.
There's a reason why I'm doing it a specific way. It's going to help you with some of the maths you're doing this year, because you have to do this transformation first. You have to do that first. But it's not necessary now. This is just something I have to teach you before we can continue with the triangle stuff we're doing. Okay, so vectors in equilibrium. And for this, we need to know the Syn rule. Okay, there's two methods of doing it. Okay, let's do an example. Okay, this is quite a popular example, but it's not difficult. And you're not going to see the difference between the methods quite as well in this example, but in the next one you will. Okay, so now we've got a 3 kg block that's hanging from a rope. A force of 25 Newton is applied horizontally along the rope to make an unknown angle. Use the diagram and determine the following: the tension in the rope, PQ. Okay, so what we had here, we had like a rope with a 3 kg block or ball there. Then someone attached another rope there, or took his fingers or something and pulled it that way with a force of 25 Newtons. That made that drawing. Can you visualize that, Amira?
Yeah.
Okay, good. So now I'm going to show you what you're going to do. These forces are in equilibrium, meaning it's not moving. It's standing still. So what you can do is draw a triangle. So I'm going to show you two methods. The first method is called the triangle rule, and the other one is going to be components again. So I'm going to use the triangle rule to solve the question. What is the tension in PQ? So the triangle rule works as follows. I'm going to take the force. Can you see there's a force in this red piece of the rope, pulling it downwards?
Yeah.
And I think you know what that force is. That force is just mg, isn't it? The mass times the gravitational force. So it's 3 times 9.8. I'm going to take that force and stick it to the ceiling. Pull it down. So I'm going to fix the point there, pull that force down. So that is mg. And then there's one force remaining. So I've got a yellow force, which is Fg. I've got this blue force here, which is the tension in the cable or the rope. And then I've got one force left, which is this green one. And I'm just going to complete the triangle with this green force. So I have a triangle that looks like this. There, there, there. And this is theta. And what is nice, I've got a 90-degree angle here. And this part of the rope is called PQ. And this is a FG. And this is 25 newtons. So can we determine FG? FG equals mg, and that is 3 times 9,8. And this is like 29 point something. 29.4. Good? Happy?
Yeah.
So now you don't even need the Syn rule because you've got a triangle now with two sides. You have a 29,4 Newton there and a 25 Newton there. And I want to know what PQ is. So PQ, let's try and write that correctly. PQ is the root of 29,4 squared plus 25 squared. Answer, please. $38.59.
Yeah. 38,59.
Okay. That's Newton. Tension in the rope doesn't have direction because the tension is upwards from Q and downwards from P. And now I want to know what the angle is. Theta. That's very easy. Tan of theta is opposite over adjacent. So shift tan 25 over 29.4. That is 40,38 degrees. That was easy. I think you could have done this example without any help.
Yeah.
Good. Right? Okay. This is the one way of reasoning. It's called the triangle rule, and that is you take the three forces that are in equilibrium and you make a triangle. I'm going to show you another way of reasoning, which it's a difficult example to actually show you the difference because it's going to look very similar because of this example is not too difficult at all. So I just want to make sure you've got the memo there. There's a memo. We got those values, didn't we? 40,38. Yeah.
Yeah.
Right. Okay. Let's just do another example. The same example in another method. Or there's another way of reasoning how to get the same values. And this is through components. So in other words, the reasoning is as follows. If this point at Q is stationary, in other words, the forces are in equilibrium, they're not moving, then this downward force here, which is Fg, is the same as the upward force from Q. So at Q, there's a force pulling it up. It's the same as the downward force. Also, there's a force to the right of 25 Newton. That force at Q would be the same as left 25 Newton. So that makes another triangle. Okay, I'm just going to draw it slightly different so you can actually follow what I'm doing. So there's an upward force from Q. There's a force to the right and a force to the left. So that and there's another PQ value there. So this force here is 25. And this upward force here is 3 times 9,8 or Fg. And then we're back at the same drawing. So this, you can just take a screenshot. In this example, you're not going to worry about, you're not going to see the difference between these two methods because they're both going to give you the same triangle. Good. Another example. Okay. Right. This is where it becomes more important, the difference between the two. Okay, good. I'm going to start off by doing the triangle rule. Okay, what I'm going to do, very important, I'm going to take my FG force. There's a point which all the ropes come together. This downward force here is called FG. And I'm going to stick it to the ceiling. I'm going to put it at any part of the two ceilings. So let's just choose the right side. You could have chosen the 40-degree side, but I'm choosing the right-hand side just to give me more space. So I'm going to take my ruler and pull a line down there. Okay, so now I've got FG here. And this is the force or the tension in rope B. And then I'm going to take my last cable or rope, which is A, and I'm just going to extend it through. So B is pulling up there, FG is going down there, and this tension rope A here is going to be there. So now I have the following angles. I'm going to write this angle here as 30 degrees. Do you agree? Because these two are 90 together. Happy with that? Then I have 90 degrees here, a 40 degrees there. So this big triangle gets 50 degrees there. Happy?
Yeah.
And then it's going to take and draw this triangle out. So I've got a 30 degrees here. I've got tension in rope B here. I've got my FG there. And I've got tension in rope A here. This is 50 degrees. Together they are 80. So this is 100 degrees. Happy?
Okay. Yeah.
This one. Down.
Yeah.
Up. Up. And there's my triangle of forces. They might ask you to draw a triangle of forces or a triangle of all the forces or a triangle of the forces in equilibrium. And that's your triangle with the arrows. And now you can use the Syn rule. You won't know the Syn rule yet. So I'm going to show you again. So I'm going to just write that FG equals mg because there's marks in here. And that equals the mass times 9,8. So 12 times 9.8 is 117,6. So let's use the Syn rule. I want to know what the tensions are in the rope. So let's start with A. A and the 30 degrees are opposite one another. And 100 and FG is opposite one another. So the tension in rope A over Syn 30 equals FG over 100 or Syn 100. So the tension in rope A over 30 or Syn 30 rather is 117,6 over Syn 100. Now I'm going to multiply with Syn 30 right through. So the tension in rope A is 117,6 Syn 30 over Syn 100. Type that in the calculator.
103,4.
Yeah, much quicker
42.
than that. 59. I get 59. What do you get?
103,42.
Okay, we all type it.
Oh, wait.
Retype it.
Let me retype it.
Please retype that.
Okay, now I get 59,70.
59,70 Newton. Okay, good. Now take this and see if you can copy and try and find the tension in rope B. It's going to be almost the same. It's going to be different values that you put in. But this section you're obviously going to keep because that's the part you've got.
For B, would it be Syn 50?
Okay. Tension in B over Syn 50. Awesome. Equals FG over Syn 100. Now,
Yes.
awesome. You're a quick learner. Okay. Help me, Amira. So TB.
So I'm not sure if I did right, but I said TB over
Pretty sure you
Syn
did.
50, which would give you 117,6 and 50 over Syn 100. And I got 91,48 if you round it off.
Yeah. I just went back to my calculator and changed the 30 degrees to a 50. Then I get 91,48.
Yeah.
Newtons. And that's tension in the rope, so there's no direction. Okay, now you must listen very carefully. The method that we've done now, we did for 30 years. This was the way we did it for 30 years. Now the CAPS have changed something in the syllabus. They reasoned as follow. Because you haven't done this in maths, you haven't done the Syn Rule in maths, and you can only do it later this year. It's not fair to expect of you to be able to do this now in physics. So they are actually, you're not allowed to do this method anymore. But impact is not going to mark it wrong. They are still going to be able, I would say 80% of all schools are still marking this method correct. But long-term, this method is going to fall away. And they want to force you to use the component method. Now you'll see the component method is a nightmare. This is much easier. Okay, so we're going to redo the sum, and I'm going to show you how to redo the sum with components. I'm sorry, I'm showing you two methods, but you have to be able to know both methods, because your textbook's also going to show you two methods. Now, the component method reason as follow. Very careful. You must give attention now. There's a downward force here called Fg. Okay, you know about that. And there's two forces countering that. There's a y component here. It's going to do a red triangle here. So there's a y component pulling up here. Let's call it the force A y component. That component is pulling upwards. And then this brown force here, we call B, also have a y component pulling upwards. So the sum of these two components, the Fg force downwards equals the force AY component plus the force BY component. Imagine that. So in other words, what it's saying, if you've got a point here and someone's pulling in that direction, and someone's pulling there, and someone's pulling there, let's call this person B, and this person A, and this person C. Then the downward force C exerts, if these forces are in equilibrium, will be countered by a y or upward component of B and this upward component here of A. Do you agree?
Yeah.
Okay. That's easy to understand. Good. There's also something else. So that's your one equation. There's also another equation. If this point here, which I'm highlighting now, if that is stationary or in equilibrium, then this pulling towards the right that B is doing, it's called the force Bx value. And this pulling towards the left that A is doing, the force of A's x component, they will be the same. If they're not the same, then this 12 kg block will move right or left if they're not the same. So the other equation is the force of AX is exactly the same as the force BX. Okay, now I'm going to complete these triangles. This is a 40-degree angle. This is a 60-degree angle. So let's do that. Let's get the Y components. So if you want to, I can make a little triangle here and say this is the force A, this is the Y component, this is the X component, and this is 40 degrees. So FG is mg, and the A component Y is Syn. So that is the force of A, Syn 40. The force A exerts, Syn 40, plus the force B exerts, Syn 60. This is this triangle here. 60, Y of B, X of B, and the force B. Are you with me how we got those Syn and Syn values? The Y component is Syn.
Yeah.
Right, this is going to become complicated. And I will give you a link to this video again. You can re-look at the video. I hate this method. I don't know why they just don't allow you to do the method. That's fine. 12 times 9,8 equals, what is Syn 40? It's 0.6447. 0.6247 FA plus
I got
60.
0.6427.
Yeah. I also got that. I don't know why I wrote the 4. And then it's still wrong, yeah. No. I just want to get something with the screen. The screen is not irritating me. Is it 6427? Yeah.
Yeah.
Whatever. And then Syn 60 is √3/2, and that's FB now.
Yeah.
Okay. Right. What is √3/2? That is 0.86 something now.
Yeah.
Okay. So I'm just going to leave it like that.
0.8660.
Yeah. I'm just going to leave it like that for now. I'm going to work with the second equation. Why? We've got 2 equations with 2 unknowns. So we're going to solve them simultaneously. But I don't want to mess up that top formula now because there's a lot of stuff in there. I'm going to look at the bottom formula. The X component is cos. So that is FA cos 40. And the B component is FB cos 60. Is that correct?
Yeah.
Cos 60 is easy. This is half. So 0.5 or half FB is the same as FA cos 40. So look at what I'm doing now. I'm going to multiply with 2. Then I get 2 FA cos 40 equals FB. Now I can write FA2 cos 40. I can do the following. I can find FB now. FB is 2. This is maybe unfair to write it like that. So it would be rather write it like this. FA times 2 cos 40. That's better. So what is 2 cos 40? 2 cos 40 is 1,5320. 1,5320 FA. So there's my second equation. So now I've got FB in terms of FA. And I'm going to set 2 in 1. Have you done something like this before?
Something in math, but not like
in math.
exactly like
Look,
this.
your physics is going to have a lot of math in now. A lot. Doesn't matter. This is not difficult. It's just difficult because it's the first time you've actually seen this. So now I'm going to do the following. 12 times 9,8 equals 0,6427 FA plus root 3 over 2. And then instead of FB, I'm going to write 1.5320 FA. So now I'm going to do 12 times 9,8. 12 times 9.8. That's 117,6. We done last time. And then I'm going to add these values, that and those values together. So I'm going to do 0.6427 plus root 3 over 2 bracket 1.5320. And that is, see if you get 1,9694 FA. I'm going to divide 1176 with that answer. 117.6 divided by the answer. I get 59,71. Did we get that in the previous example? Yeah, 59,70. We are slightly out. Why? Because we rounded off to 4 decimals straight through, but that will be marked correct. Okay, good. Have a look at this and then tell me that from here you can do FB easily. FB is just 1,5320 times that answer of 59,71. Huh. $91,48.
Yeah.
This is not a good method. The Syn rule is much easier. You have to be able to do both. Must be able to do both. Okay.
Right.
Okay. So what we're going to do now, I'm just going to show you another example. Take a screenshot of this.
I took one.
And then I'm just going to try and flip it around. There's a wall there. Got two ropes here. Tension in rope 1, tension in rope 2. And then someone's pulling there with a force of 300 newtons. This angle here is 70 degrees. And this angle here is 40 degrees. I want to know what is the tension in rope 1. All I'm expecting you to do now, for starters, is just to get that triangle done. So I'm going to choose to do what? Do you remember?
Imagine you just sketch it first to see all your forces.
You're going to take what?
Aren't you like just supposed to roughly sketch it first just to get all your forces?
Yes, awesome. I'm going to take this force going in one direction, which is similar to the gravitational force if I just tilt this thing 90 degrees. Do you agree?
Yeah.
I'm just going to stick that to the ceiling. Well, let's take the top part if you want to. You can take top or bottom, doesn't matter. Foop, there we go. There we go. That's now 300 Newton. Agreed?
Yeah.
And then I'm going to take this remaining force and just push it through. This is T2. So now I need to get angles. This is like 20 degrees, isn't it? And it's going in that direction. And this is 90 here and a 40 there. So we have a 50 here. 50 plus 20 is 70. And then that means it's 110 degrees. So if I want my triangle, I've got one there, something like this. This force is pulling that direction. This rope is pulling in this direction, T2, and that rope is pulling in that direction. This is 300 newtons. This is 50 degrees. This is 20 degrees. And this is 110 degrees. This is tension in rope 1, and this is tension in 2. Now, if you can do this, If you can make that drawing, complete that drawing, then you can do the Syn rule with it. It's just really easy. So tension 1 over Syn 50 equals 300 newtons over Syn 110. Okay, complete that. I get 244,56. Please try and find this value. 244,56 Newton.
Yeah, I got the same thing.
Okay. You got the same value. Awesome. Okay, good. Give me a minute, please. I want you to look at the following. See if you can actually solve the following one. Let's just make a new page. There's a wall there. Then let's say I've got a piece of metal there. And there's another support structure there. Do you understand? This is like a metal rod and another support structure there. And then I've got a weight there of say 50 kg. What is so easy about this example? So let's say this is a support 1. I'm just going to say tension. It's easier. This is like a metal rod, but there's some tension in here. How will we determine that tension? Let's assume that this is a 70-degree angle here. And why is this such an easy example, Amira?
If you draw a line at the bottom, it will be 2 triangles.
Yeah. Are you referring to a line here?
Yeah.
Yeah. So that's the line we drew in. This one, you can determine this green one. It's not difficult. Why? Because that's like FG. And this is now suddenly 90 degrees also here. And we have a 20-degree angle there. Agreed?
Yeah.
So 20 degrees, FG. Let's just get our direction correct. This one is pulling down. This one's, let's make sure, yeah. This one's pushing up. That support is pushing up. And this one's putting in. Okay, anyway. I want this tension here. So this is simple maths or simple trick. FG is mg, and that is 50 times 9,8. And that's 588, I think. No, 490.
490.
Okay, so that's going to be 490. And then you're just going to do sin of 20, which is 490 over t. Please solve that.
Is it not 490 sin 20?
490 divided by sin 20. See if you can see that. 1,000 432. Okay, so let's just make this equation simple. 5 equals 100 divided by x. So if we multiply by x through, then we get 5x equals 100, and then x equals 100 divided by 5, and that is 20. Or you can just say the top one divided by that one will give me the other bottom one. So t is 490 divided by sin 20. That is 1,432,66 Newton. Just showed you another easy one. So they are focusing a lot on these easy ones because of the confusion in the syllabus. But your textbook that you're using, are you using Doxentia or something like that? What's your textbook?
The one that I have,
It's something like Doxentia.
Yeah.
They will still have all the older stuff in. Not older. They will show you those old methods. Do you understand? They will have examples in of the Syn rule we've done, triangle rule. They'll have all those examples in. So it's important that you know these. Right, happy.
Yeah.
Okay, so what I'm going to do now, let's put your number here now. Let's just remember to save it. I'm going to give you some more work to do. You only do this work after you've completed your exercises in your textbook. And also, very important, yeah, I don't have an English one for this. I'll have to make an English one. So I'll send you one soon. But you have to complete all the stuff on vectors in your textbook before I see you again. Okay. It's really important that you spend at least an hour a day doing physics. If you look at it, you'll find there's a lot of examples. And you have to work through them. Okay. You're kind of clever and you learn quickly, so you'll be able to just burn through those examples in your textbook very quickly. Let's just see, I've got one example left, I think, that we didn't do. No, we did that one, we did that, we did that. So we are basically finished with vectors. Awesome. Okay, one more thing. You won't easily find this, but I'm going to show it to you anyway. You might have examples on this, but in exam, you don't really find this. Let's assume that there's a point here. And I'll tell you now why you don't really find this in exam. I'm going to draw a couple of vectors. There's one. Let's say there's a force. It's 100 newtons. And the angle here is 30 degrees. Then I have another force. It's south. Let's say force 2. And that's 80 Newton. Then I have another green. No, I don't have another color. Blue one. West, force 3. And let's say it's 50 Newtons. And then I've got a fourth force here. Force 4, 70 Newtons. And the angle here is 60 degrees. Now, the reason they don't often give you this is because once you've got the concept, you're going to just rake in the marks, because now they want to know what is the resultant force. But you know what to do. You are just going to have, you've just now got 4 forces that you have to get X and Y components for, and then add them all together and then make a resultant of that. So the more forces they add, the more marks you're going to get. And that's why they keep it to 3 forces, because they don't have enough marks to allocate in the exam for vectors. You'll find that at the end of the year, your vectors will probably consist of short questions and maybe one question 4 marks. Because the stuff we're doing after this will consume more marks. Are you happy, Amira?
Yeah.
Okay, we're going to stop here. You're going to complete vectors. The next section we're going to start with is Newton. Your textbook is either going to start on Newton 1 theory, or it's going to start with Newton 2 examples. That's where we are next week. Okay.
Okay.
Well,
If I have a question or anything
Yes.
while I'm doing my work, can I message you?
If you have a question during the week, you can message me. I can't always guarantee that I'll be able to answer on that specific day because I'm also busy, but I'll make some time. So what students normally do, they heap up the questions until our class starts, and then they've asked the questions. We do all the questions first. But if you are
So how do you do
struggling
that?
during the week with something specific, then text it to me. Okay.
Okay.
Okay, Mira.
Thank you so much.
Bye-bye.
Bye.